All right, guys, we are back again. Today is May 11th, 2020, and we're going to be talking more about two-way tables and Venn diagrams today. So this is a great warm-up. Pause the video, take a couple minutes, and try to create a Venn diagram and two-way table that models the situation. All right, trust me, it's worthwhile trying to work through this and figure out things on your own. So go ahead, take at least 5 minutes and try this warm up. All right, so first we're going to create a Venn diagram. So I will make 2 circles. And what are we going to label these circles? Well, so we're looking at tourists who visited Florida on July 4th last year. 38% of them are going to visit an amusement park, and 54% are going to visit a beach. 70% will visit either an amusement park or a beach. Then what percent will visit both an amusement park and a beach? So we're looking for, well, one circle I can call amusement park, AP, and other I'll call B for beach. And that is an unfortunate abbreviation. Sorry if you're thinking about that now. Also, I know we can't go to amusement parks or beaches, so overall, just not a very fitting question. But anyway, we're looking for what percent are going to visit both an amusement park and beach. So we're looking for the overlap, right, of these two sets. We're looking for the number that's going to go in here. So first of all, 38% are going to visit the amusement park, right? Does that mean I should put 38% here? No, right? Because I know the entire circle is going to be 38%. So what I'm going to do is I'm going to put 38% right outside this circle. So I know that entire circle, right, should add up to 38%. Right, same thing for the beach, which has 54%. All right, so how can I figure out this middle piece now? Well, I know the entire thing, people who visit an amusement park or a beach, right, isn't that going to sum to 70%? Right, because the 70% will visit an amusement park or a beach. Well, I can write that as the probability of amusement park or beach. Right, and if you remember from last lesson, we said the probability of an or statement, that's the probability of people going to an amusement park plus the probability of them going to the beach, right? But there are some people that go to both the beach and the amusement park. So we need to subtract the overlap, probability of amusement park and beach, right? So hopefully that makes sense. So I can figure out that using this formula here, right, that 70%, that's the probability that people go to amusement park or beach, is going to equal, well, 38% probability of someone going to amusement park plus 54% probability of someone going to the beach minus, well, isn't that what we're looking for? The probability of amusement park and beach. So I'm going to solve this simple equation now, and I get that the probability of someone going to both the amusement park and the beach is, let me grab my calculator. Sec, and that is 38 plus 54, 70 minus that result. And I'm getting 22%. And so 22% of people are going to go to both the amusement park and the beach, right? Which means 16% go to just the amusement park because these two numbers, again, need to add to that. And over here, 32% go to just the beach, right? Also, I know I'm using percentages. Most of the time, if you're doing one of these Venn diagrams, we're going to write everything as a decimal between 0 and 1, right? That is more often how we're probably going to do these problems. So let me just write it like that now. 0.38, 0.16, right? 22% is 0.22. And change that to 0.32, and change this to 0.54, right? Means exactly the same thing. And we could have done all these calculations in the same way, just by writing them as decimal values. Does not change a thing, right? But if you want to use percentages, I guess that is also fine. It really does not make any difference whatsoever. But it's a little quicker running it this way, I suppose. So there's our Venn diagram, or at least there is part of it, right? A lot of people tend to forget the other important piece, which is this, right? And so now if I add up these three numbers, that is going to equal 0.7, right? At least I hope it equals 0.7, 0.54, yeah. It's going to equal 0.7 because that is 70%, right? We'll visit either a park or a beach. So we know outside, I need to have this number 0.3, right? And this number represents the people who do not go to an amusement park or a beach when they visit Florida on July 4th, 2019, right? This means 30% who did not go to a P or B, amusement park or beach, right? And outside, this is our entire set. So if we add up all the numbers, this plus that, all those circle numbers, that is going to equal 1. And of course, it should equal 1 because that is 100% of the people that went to Florida. So that's our entire sample. So what we just did is we displayed the data above using, well, we didn't give the number of people, right? We gave the fraction of people or the percentage of people. So we call that a relative frequency. Relative frequencies. So relative frequencies are just a fraction or percent. In this case, we wrote the percent as decimals. That's just a fraction or percent of, how do I want to write this? Hold on, I have this up somewhere. Give me a second. So there it is. A fraction or percent of times a specific event occurs. Right, out of like the total number of events happening. So it's a fraction or a percentage. And let us make this into a two-way table. Right, I find that some people do tend to have difficulty converting into a two-way table. A lot of times it can be confusing even just getting the headings, right? Because some people are going to do something like, I don't know, amusement park beach, and then visits, and doesn't visit or not visits. But this setup isn't going to work because how are you going to represent people that visit both the amusement park and the beach, right? So if you looked at the notes from last time, it makes it a little easier, but the way we set this up is amusement park, and then people that don't go to the amusement park, right? People that go to the beach, and people that don't go to the beach, just write no B. And so that's really all you need to make a two-way table. It has to be at least 3 by 3 for a two-way table, but I always make mine 4 by 4 because you definitely want to add this last column and row, which are the totals. Right, so I'm going to ignore this for now. I'm just going to use the original data from the warm-up again to make my two-way table. So I know that 38% will visit an amusement park. So the total that visit amusement park is 38% or 0.38, right? 54% will visit a beach, so the total for a beach is 0.54. Also know the total is going to be 1, because this is a relative frequency table, right? The sum of all the relative frequencies over here, right, should sum to 100%. So that means this has to be 0.46, the number of people who don't go to the beach. And if you look at our Venn diagram, if you add up this and that is 0.46, right? This is all the stuff that is outside this beach circle. So, of course, that is going to be 0.46. And we can do the same thing for amusement park. That is going to give us 0.62. And here's where we need to use the 70%. 70% will visit an amusement park or a beach. So it's kind of really tricky here. Amusement park or a beach. That means the sum of these 3 boxes is going to equal 70%, right? Because in this cell here, right, those people visit both an amusement park and a beach. And this cell here, those people visited a beach. And this cell here, these people visited an amusement park. So all of those either visited an amusement park or a beach, which means these 3 cells should sum up to 70%, which means that this cell should be 30%. And then once you have that, you can fill in the rest by addition. So that's going to be 0.32, that's going to be 0.16, and this will be 0.22. All right, so I encourage you to see how the numbers match up from our two-way table onto our Venn diagram, right? All the information is presented in both, right? Just sometimes you need to add the numbers, it might be a little different, but there we go. Right, and if you have trouble making the two-way table first, maybe make the Venn diagram first. If you have trouble making the Venn diagram first, maybe make a two-way table first, just however your brain works. Or if you're fine with both, then you can do either one first. All right, so what we did above, we made relative frequency tables. We represent our data using relative frequencies. But suppose 500,000 tourists visited Florida on that date. Convert the data above using this hypothetical. So what I'm going to do if there are 500,000 tourists is, well, I know the percentage of those 500,000 tourists that went to the beach or the amusement park. So all you have to do is multiply everything by 500,000. So instead of 1 here for 100%, well, now we're giving the total actual number of people, right? So to convert this to what we call a frequency table, we're just going to multiply all these percentages by 500,000. And that is going to look like, should look like this. All right, so I just paused it, filled in those numbers. All right, so that is out of 500,000 tourists, 80,000 people went to only the amusement park, 190,000 went to the amusement park, right? 270,000 went to the beach, right, etc. So do the same exact thing for a two-way table, just multiply everything by 500,000, right? But this is going to be called a frequency Venn diagram. So that is the frequency. So relative frequency, we write that as a fraction of percent of the total, right? Frequency is the actual number, right? This is the actual number. So the frequency of something is the number of times an event occurs. So frequency is the number of times an event occurs. Whereas the relative frequency is the fraction that that event occurs, or the percentage that event occurs, right? So now that we know that, let's take a look at this first question. Write each in words and then find the probability. All right, so let event C equals owns a cat, let event D equals owns a dog. So P of C and the symbol D, right? We should know what that symbol means. That means and. So that means what's the probability of owning a cat and a dog? Well, let's take a look at our diagram. 5 people own both a cat and a dog. So this probability is 5 out of, well, we got to count up the total number of people. So 10 plus 5 is 15, plus 7 is 22, plus 8 is 30. So we should really add a 30 outside here. And if you want, you can also write 15 outside the cat circle for 10 plus 5, and 12 people own dogs. So what's the probability of owning a cat or a dog? So chance of owning a cat or a dog is 10 plus 5 plus 7, which is 22 out of 30. All right, probability of the complement of owning a dog, right? That's the complement of event D, which means this is the probability of not owning a dog. And so what this is going to be is everything outside the dog circle, right? My dog circle is 12, so naturally I can just do 30 minus 12 to get the complement, right? Or the complement number of times that event occurs, which is 18. So 18 people don't own dogs. That chance is 18 out of 30. All right. This is our conditional probability, right? This vertical line means given. Just write out what this means in words. What's the probability of someone owning a cat? Someone owns a cat given, right? Under the condition, given that they own a dog. All right, so in this case, we are not going to be looking out of the 30 people, right? Because 30 people don't own dogs. We're looking underneath the condition that they already own a dog, which means we're looking at this population of 12. So out of those 12, 5 people own a cat, and that's 5 out of 12. Did I not write this 30 earlier? I don't know. All right, and what's the probability someone owns a dog given that they own a cat? So now we're looking at all the people who own cats. And so now we're looking at these 15 people, right? And out of those 15 people, 5 of them own dogs, so that probability is 5 out of 15. Right, so if you want to write this out in words, you can just copy and paste that and swap the words cat and dog. And lastly, what's the probability of someone not owning a cat and not owning a dog? So that's the probability that they own no cats and no dogs. And so if we take a look, that is going to be 8. 8 people do not own a cat or a dog. So that's going to be 8 out of 30. All right, so I have this blank thing here because I want to talk about some probabilities in terms of Venn diagrams. So draw a Venn diagram. Starting with a rectangle. Come on. Draw a rectangle. There we go. And 2 circles. 1, 2. So we're going to take some notes here. So here's a Venn diagram. I'm going to call the 2 events of this Venn diagram A and B. So if we're looking at the probability of A and B, sorry, I'm not looking at probabilities here. I'm just looking at the intersection of A and B. So event A and B together, right, that's going to be represented by that piece of the Venn diagram, right? So if I want the probability of event A and B, it would be this number divided by that number outside, right? The total. So just a visual of how we can represent each thing. So that's going to be and, right? How do you think we would represent A or B? Well, here is all of A. Here is all of B. Right? And if you'll notice, I highlighted that middle section twice, so I shouldn't do that because then I'm double counting. So A or B is just adding up these three numbers like we talked about earlier. So everything in those two circles is A or B. Right, and what if we wanted, I'll do a couple more. I could do a whole bunch of these. But what if I just asked for event A? So event A would just be all of that, right? I want to do just one more. What if I asked for the complement of A? Well, that would be everything but A colored in, right? So the complement of A would be, I wish there were like a paint bucket tool on Notability, but hopefully you get what I'm trying to color in, right? That would be the complement of A. Right, so the reason we're doing this is because I want to come up with a formula for conditional probability. And what we're doing here is hopefully going to help us. I'll just stick that there. All right, so let's come up with a formula for conditional probability. So let's say I wanted the probability of A given B. Well, what is that going to look like on our Venn diagram? Probability of A given B. Well, if I'm given B, right, I know I'm looking out of all the people. So hold on, sorry, let me change this to just B instead. So probability of A given B, if I'm given B, I know I'm looking at this population, right? The highlighted population. That is B. So out of that set of population, how many also satisfy event A, right? Because I want to know the probability of A. Well, that's going to be that probability, right? And that probability there, isn't that the probability of P and A? So the way this works is our formula for the probability of A given B is it's going to be the probability of A and B divided by the probability of B. So normally when you do the probability of just A, right, sorry, I'm going to forget that, scratch that. So probability of A given B is probability of A and B divided by the probability of B. So is there anything else I want to say about that? No, I guess that's pretty much it. So it does not matter whether you're dealing with frequencies or if you're dealing with frequencies or probabilities or relative frequencies, right? This formula still holds up. So for example, in this case, I dealt with frequencies. So probability of D given C, right? That was probability of having a dog given that you had a cat. So out of the 15 people that had cats, right, 5 had dogs. So we used frequencies here, and that was 5 out of 15. The same thing would work if all of these were percentages. We could just set it up with the percentages, and we get the same result. So really, for this, I can also say this is equal to the frequency of A and B divided by the frequency of p, right? They're all going to be the same. So that is going to be our formula for conditional probability, right? So we're going to be using the formula a lot more later on, but right now I think hopefully it makes sense. Just thinking about conditional probability and not having to use a formula, right? We can still get the answer that way as well. All right, so it's getting kind of late. So for homework, guys, I think we have done everything we need to know to do this. So I'm going to stick question number 2 on the homework. And it's going to be a pretty short homework due for Wednesday. So that's going to be it for today. Take care, and I'll see you guys later. That is not how I stop recording. It's from here. All right, bye, guys.